have a Stromberg Carlson. It's about 1937 to 38. It's a quick look at it. It's in really nice shape. The cabinet's beautiful. I mean, it needs nothing. Volume. This is band tuning. Oh, that's the power switch. Off, on, tone. Oh, okay. Yeah, so it's got AM here, and then shortwave below it. Okay, so let's take a look behind here. Here's the inside. Very clean, good shape. You can see the cord's been replaced. It's got this non-period original cord, which is usually I don't like these, so I may change it. I don't know. There's the tube lineup. Pretty typical 80 rectifier, 6A8, 6K7, 6Q7, 6V6, so it's probably 1938 or 39. You can use the Stromberg Carlson antenna. You can also connect a record player. I'm not sure where you do that because I don't see any kind of connection. Anyway, believe it or not, I was told this works. Here's the chassis. Speaker looks really nice. Okay. It's an electrodynamic speaker. Have our tubes here. This is in really great shape. This actually looks really good. So let's flip it over and we'll see what it looks like underneath. Apart from this cord, and yeah, apart from that cord, it is all original, including the leaking filter caps. So yep, definitely not going to be powering that up. Stromberg Carlson was kind of a high-end brand. They competed with, you know, RCA and Zenith and whatever, but their quality was a little higher. So you can kind of see the wiring here, nicely laid out. They really took their expertise from the telephone industry and built high quality radio. This thing right here, that is a bias cell. So that was usually a way to cut costs on, basically replace the capacitor and a resistor, and it was cheaper. So what it would do is usually set the bias for the audio stage. I don't know what it does in this one, but it still may be good. Sometimes they are. I have an electrolytic over here. That's this here. Power transformer looks really good. I mean, everything looks pretty good. It probably does work. Like I said, Stromberg Carlson was a really nicely made set. And even a cheap Stromberg Carlson was better than a lot of higher end other brands in terms of quality. Plan of action with the Stromberg Carlson. So you've got filter cap here, one there, an electrolytic here. It's probably a low voltage. Coupling cap here, that needs to be changed. That is definitely getting warm. So clearly that's no good. You can see this one also got pretty warm, so I'll probably replace that. Over here is the output tube right at the top. So you've got, I think these are probably for tone, I can't really tell. And then the bias cell on schematic, that it actually goes to the volume control, which is weird. There's the volume control there. I don't really know what it's doing, and I probably should figure that out. clean the controls. Obviously got to do that. So I'm guessing the power transformer and the audio transformer are okay, but I will check them anyway. Yeah, I just got to figure out how to replace these electrolytics because there's nowhere to mount them. I mean, there's, you know, these wires come right off of that. I don't want them sticking up in the air. So I put a terminal strip down here. I put in these two capacitors. Now these were 16 at, one was a 16 at 200, 16 at 350. I put in a 22 at 500, 22 at 500. I stopped buying the 450 for the most part. I usually buy just 500 because on a lot of these sets, the first filter cap gets a surge voltage on it and power up at usually 480, 490 volts, and I'd rather have a 500 volt rated cap. I changed this one resistor. I hate this. I hate doing this, the J hooking, but the leads were not long enough. Same goes for here, so I did this. It's not great. It's not what I really like to do, but again, same situation. Now over here, what have I got over here? Well, I want to attach a cap here, and ground is over here, so we're going to attach it between here and here. Now, since I'm undoing some of these other terminals, why put a new cap in only to take it out and put another cap in? So what I'm going to do is I'm going to replace these capacitors as I go. Now, I had to replace this wire. The other wire was not long enough. What I want to do is solder this wire to here. Now, over here, because again, same story, change this resistor. It's 100K. It was reading 122K, too high. I would like to change it, so I did. This resistor was connected to this capacitor, which I've just replaced. So here's the old one. It's here. I'm going to take that out, and so on. I'm going to focus on this, though. I'm going to get this mess cleaned up. Now this is kind of interesting. This one right here is 2 in 1, 2 times 0.05. So you have one here, one here. If I'm going to replace this half of it, I might as well replace the other half of it. I'm not powering it up with these electrolytics, the wet electrolytics, which are ancient and definitely no good. I mean, these usually last 30 years or so, but these old ones, they had a life expectancy far shorter. Usually they were about 10-15 years, and that was it. And this radio is 90 years old. I replaced these 3 capacitors. You can see, repositioned this one, so now this one goes from here to here. It's fine. Change these 2, change this one, obviously change that resistor. Got to do some cleaning up in here. Okay, where are we right now? We've got a bunch of capacitors changed because they were in the way. So I talked about this resistor, this one. This resistor was out of tolerance. It was on, come on, focus. It was on the same terminal as this capacitor, so that got changed. This capacitor here was melting, so I figured, focus. I figured I would just change it. Cathode bypass resistor and capacitor. This is an electrolytic. I changed that. We're going to go ahead and power this up. I've got my meter connected to the second filter cap. I have my dim bulb tester connected, and I've got my Variac over here. So, before I do that, I'm just going to go ahead and attach an antenna to it real quick. Might as well be optimistic, right? See if that does anything, right? Okay. So we're looking for some B+. Go ahead and turn this on. Radio is turned on. We'll give it 10 volts. Give it 25 volts. Remember, I didn't change all the capacitors. I just changed some. And some resistors, of course. 40 volts. We're at 50. This is good. You can see that the voltage is dropping down as the tubes start to conduct. So that's what we're looking for. 60 volts, 65.
The afternoon roundup starts right now on WCBS.
So we're at 90 volts.
5:31, we are bracing for that nor'easter. Our chief meteorologist Craig Allen joining us now with the latest. Anything changed in the last few minutes, or it's all the same?
Not too much just yet. And the latest full package of new information comes out a little bit later on tonight. But as of now,
we're at 110 volts.
Developing stages, and that would be off the southeast coast, and it's going to take a track probably enough to the east so that we are spared the worst of it. Unfortunately, this is going to be a real New England special along the New England coastal waters, but we'll get our share.
Okay.
And eastern sections of Long Island and eastern
You've got a radio.
Jersey Shore.
Don't want to play it for too long. Still haven't changed the rest of the capacitors. Radio itself seems to work fine. I did notice when I was putting it up on its side here, I don't know if you can see it. It's a 6K6, not a 6V6. I know they can often be interchangeable, but you won't get the fidelity that you'd get from a 6V6 from a 6K6. So I have a ton of 6V6s, so I can swap that over. But this was a good first start.